Okay, so here's the solutions to the homework assignments. So the first thing is we're finding the exact values of these two expressions, and basically the idea is to demonstrate the sum and difference formulas, and also to show that you can't, to find the sine of an angle of two angles added together, you don't do the sine of each angle separately. So now we can get these here from the unit circle. We could add these together and find the result, which it will do as a comparison, but we're going to use is the sum and difference formulas as well. So here we have the sum of two angles. So we look at the sum and difference formulas and find the one that is appropriate. So we have the sine of u plus v is equal to the sine of u cosine of v plus the cosine of u times the sine of v. So that's off the formula sheet. In our case, u is 3 pi over 4 and v is 5 pi over 6. And if we do u plus v, that's going to be, well, actually we can't find that off the unit circle. That's one reason we're doing this. So if you found, if you did this, so if you add these two together, you'd have to find a common denominator of 12. So this would be times 3, so you get 9 pi over 12. 3/4 is 9/12. And then you'd have 10 pi over 12. So it'll give you 19 pi over 12. So we don't have that on a unit circle. It is between 0 and 2 pi because 2 pi would be 24 pi over 12. Okay, so, but we know the sine of 3 pi over 4, and you can use your unit circle. And we know the cosine of 3 pi over 4, and we know the sine of 5 pi over 6, and we know the cosine of 5 pi over 6. Now I'm not going to use my unit circle, I'm just going to show you how to think about this. So this is the coordinate axes. 3 pi over 4 would be right here, and 5 pi over 6 would be right there as far as on the unit circle. And that's because 180 degrees, or pi, is all the way around to the negative x-axis. And I know this is pi over 2, so pi over 2, 3/4 is between a half and 1. It's exactly halfway between. And then 5 pi over 6, well, 6 pi over 6 is pi, so I know it's just pi over 6 towards up in this direction. So if I were to draw a circle, so I'm going to draw a nice circle here, and you think about what the values are, well, remember the cosine is the x-coordinate, so this is going to be negative square root of 2 over 2, and this is going to be positive the square root of 2 over 2, because the coordinates at this point are negative x, positive y, negative x, positive y, and they're this fourth, these fourths, which you're going to, they're equal to each other because they're halfway between the coordinate axes. And then down here at 5 pi over 6, the y coordinate, which is the sine, is a half, and the x coordinate is negative the square root of 3 over 2. So those are the trig values. So now we can answer the first part by using this formula. So we're going to get the sine of 3 pi over 4 times the cosine of 5 pi over 6 plus the cosine of 3 pi over 4 times the sine of 5 pi over 6. So let's do that. Just all we have to do is look at these. Square root of 2 over 2, that's the sine of 3 3 pi over 4. The cosine of 5 pi over 6 is negative the square root of 3 over 2. And then I add cosine of pi over 3 pi over 4, which is negative the square root of 2 over 2. And sine of 5 pi over 6, which is a half. So here we'll get square root of 2 times square root of 3, which is square root of 6. We've got a negative sign here, divide by 4, 2 times 2. And then we have a negative here in the second one, square root of 2 over 4. So that becomes, you could say it's negative the quantity square root of 6 plus square root of 2 divided by 4. So that's the sine of 19 pi over 2. And, where is that? Well, this is 3 pi over 2, which is 18 pi over 12. So it would just be slightly to the right. So it's in the fourth quadrant, and therefore the sign should be negative. I've got a negative y coordinate, and it is negative. And it should be very close to 1. So if I actually plug those in there, let's try that out. The square root of 6 plus the square root of 2, which is 3.86 divided by 4. So I get negative 0.966, which is very close. That makes sense because this 3 pi over 2, it's negative 1. So this should be slightly greater, more positive than negative 1. Okay, so that's the A part. The B part is to just take the sine of 3 pi over 4, which is the square root of 2 over 2, and add the sine of 5 pi over 6, which is a half, and so you get the square root of 2 plus 1 over 2. So let's do that in decimal form just to see what it is. Square root of 2 plus 1, then divide by 2, and you get 1.207. Which obviously is wrong because the sign is always between negative 1 and positive 1. Okay, so that's the first problem. The next one, same kind of deal. We're going to have a result that is something that's not on the unit circle, because you have 120 plus 145, which is 165 degrees. And the unit circle is 90, add 30, 120, 135, and 150. Okay, so, and then 180. So those are the unit circle values. This is between these two. Because that's 165. Now, just thinking about it, if I draw my unit circle, and 165 is going to be about right there. So you should have the cosine should be negative and the sine should be positive. The cosine should be close to negative 1, and the sine should be small, relatively speaking, less than 1/2. Now here we have the cosine of two angles. So we go to our page and look for the appropriate formula, and we have the cosine of u plus v is equal to the cosine of u cosine of v minus the sine of u times the sine of v. So in our case, u is 120 degrees, v is 45 degrees, u plus v equals 165 degrees. So we need the cosine of 120. So if we go to our unit circle again, we'll just draw a small version of it here. Just need a pair of axes with a circle drawn on it. And let's draw where these are. So 120 is going to be right. So this would be 135, 120 would be up there. And then 45 is going to be here. So looking at the position on the unit circle, it looks like the cosine of 120 is going to be negative a half. The sine of 120 is going to be positive the square root of 3 over 2. And now to 45, they're both positive. Cosine of 45 is square root of 2 over 2. And the cosine, the sine of 45 degrees is equal to the square root of 2 over 2. Okay, so now we can plug those in. So the cosine of 165 degrees is equal to the cosine of u, which is negative 1/2, times the cosine of v, which is the square root of 2 over 2, plus minus, make sure I got that right, look at my, yep, minus, there's minus sine of u, which is square root of 3 over 2, sine of v, which is square root of 2 over 2. So we're going to get the square root of 2, negative the square root of 2 over 4, and then we have minus the square root of 6 over 4. So we get negative the square root of 2 plus the square root of 6 over 4. So that's the cosine of 165 degrees. And again, if we go back to our unit circle, 165 degrees is going to be right here. So the cosine is the x-coordinate. It's going to be slightly more positive than negative 1. And we've already did that. We've already done that in the previous problem. This was equal to negative 0.9659. And so that's this point right here. So that makes sense. And then we do the same thing. We can take, the cosine of 120 and add the cosine of 45 degrees to it. So the cosine of 120 is negative 1/2. And the cosine of 45 is plus the square root of 2 over 2. So I get the square root of 2 minus 1 over 2. So I've got a common denominator. I changed the position so the positive thing was first. And obviously that's not equal to that. This is going to give you a positive quantity. This is negative. Okay, next group. Find the exact values of the sine and cosine of the angle, tangent of the angle. So they show you what math you have to use. So 255 is not in the unit circle. Let's kind of sketch where it is, just to give an idea of what. So since we're in degrees, 0, 90, 180, 270, 360. So 255 is going to be here. It's actually very close to what we had earlier. And they're saying take 300 and subtract 45. I think what we did earlier was we added two angles together, but you can get the same angle by subtracting. And 45 is here, so it's 45 degrees. 300 would be down here, so that's 300. And again, let's draw a circle just to. So how did I? This one's easy because you just go diagonally between these 2 points. How did I choose on this? Well, if I broke this down into, if I cut this in half, that's easy to do. And 300 is to this side because this would be 315. So this, if I cut it halfway, it'd be 315, halfway between 270 and 360. 370 plus 45 is 315. So I know it's got to be a little bit further down here. And what that does is it allows me to qualitatively figure out what's going on. So, you know, here's the y coordinate, here's the x coordinate. So you can see this is a half. This would be a half, positive a half, and this would be negative the square root of 3 over 2, and then this point would be square root of 2 over 2 and the square root of 2 over 2. They're both positive in the first quadrant. Okay, so given that, the sine of 255 is going to be using the formula. So which formula do I use? Let's write that down. So we go the sine of u minus v is the sine of u cosine of v minus the cosine of u sine of v. So since I'm breaking this up to that, it's going to be the sine of 300 degrees cosine of 45 degrees minus the cosine of 300 degrees times the sine 45 degrees. So the sine of 300 degrees is negative the square root of 3 over 2. The cosine of 45 is square root of 2 over 2. Then they subtract the cosine of 300, which is a half, times the sine of 45, which is the square root of 2 over 2. So I'll get minus the square root of 6 over 4 minus the square root of 2 over 4. So that's negative the quantity square root of 6 plus the square root of 2 over 4. That's what we got. We got that before. The sign is negative that. Okay. Now to do the other ones, we just use the appropriate formula. So the cosine of u minus v is the cosine of u cosine of v plus the sine of u sine of v. So again, we can go over to the unit circle here. The cosine of 300 is a half. The cosine of 45, or 45 is square root of 2 over 2. And then I add the sine of u, that's the sine of, so that's minus the square root of 3 over 2, that's the sine of 300, times the sine of v, which is going to be positive the square root of 2 over 2. So we'll get the square root of 2 over 4 minus the square root of 6 over 4. And based upon where this difference is, 255, it should be the cosine should be negative. It's going to be the x coordinate. So I could put that into 1. Square root of 2 minus square root of 6 over 4, and because 6 is greater than 2, this will be a negative thing, which goes along with what I thought it should be. And then the tangent of u minus v is the tangent of u minus the tangent of v divided by 1 plus the tangent of u times the tangent of v. Okay, so what are the tangents here? So the tangent of 300 is going to be the sine divided by the cosine, and because we're in the fourth quadrant, it's going to be negative. And because the sine is greater than the cosine, it ends up being minus the square root of 3 instead of the other option is the square root of 3 over 3. And the tangent of 45 degrees is 1 because both the sine and the cosine are the same, and they're both the same sine. So the tangent of u is minus the square root of 3 minus the tangent of v, which is 1. So this is negative because the tangent of 300 degrees is negative. This is negative. We subtract the positive. Then we have 1 plus the tangent of v, which is 1, or this is the tangent of u. Tangent of u, which is negative the square root of 3 over 2. No, it's not. It's negative the square root of 3 times tangent of v, which is 1. So here we get negative the square root of 3 minus 1 divided by 1 minus the square root of 3. So that would be the answer. And we could check it out on our calculator because we could do the tangent of 255 if we want to. Let's just check it out and then we'll simplify it. So you get minus the square root of 3 minus 1 divided by 1 minus the square root of 3. And the tangent's positive in the third quadrant, and 255 is in the third quadrant. So I should get a positive number, and I get positive 3.732. Okay. And if I take the tangent, make sure the calculator's in degrees, which it is, the tangent of 255, I'll get 3.732. Okay, so I did do that right. Now, to clean this up a little bit, what I would do is I would multiply and divide by 1 plus the square root of 3. And what that is going to do is it's just going to give me an integer in the denominator. So in the numerator, I have, using FOIL, I get the square root of 3 from the first. Outer, I get minus 3, negative square root of 3 times positive square root of 3. Inner, I get negative 1. And then last, I get minus the square root of 3. And in the denominator, I get 1 plus 3. Because the inner and outer cancel out. So I get 1 times 1, which is 1. Negative the square root of 3 times positive the square root of 3 is, actually, it's negative. Because I get 1 minus 3, which is, I get that. And so in the numerator, I get 4. That's not working out right. Let's see, what did I do wrong? Oh, this is the first. That's negative the square root of 3. Okay. So what I'll get is I'll get negative 2 square root of 3 minus 4 over negative 2. Or I can divide by 2, or negative 2. So I'll get the square root of 3 plus 2. So let's see if that works out or not. Square root of 3 plus 2 is 3.732. Yeah, so that does work out. So it's still the same number, 3.732. Okay, but this is, you can see this result is a lot better than this result. So the whole idea was to multiply and divide by the, it's kind of like a conjugate. It's not a Pythagorean conjugate. Maybe it's called a root conjugate. I don't know. Okay, so that's the first one. That's basically how you do the rest of these. So what we're going to do is we're going to use those same 3 equations, except in this case we're adding stuff together. So we're going to use the ones that are appropriate for those, for the addition. So let's first figure out what the sine of 3 pi over 4 is, the cosine of 3 pi over 4, the tangent 3 pi over 4, so get those, and then we need the sine of pi over 6. Don't ask me why I put the parentheses there, and I didn't tangent of pi over 6. Okay. Again, you can look these off of the unit circle. So in this case, I'm just going to give you the answers. You can look them off of your sheet. So this is going to be the square root of 2 over 2. This should be negative the square root of 2 over 2. This is negative 1. This divided by that becomes negative 1. Pi over 6, the sine of pi over 6 is a half. The cosine is the square root of 3 over 2. The tangent of pi over 6 is the square root of 3 over 3. So if I divide sine by cosine, the 2's cancel out. I get 1 over the square root of 3, which simplifies down to that. Okay, so now that I've got all that, all I have to do is use the appropriate formulas for adding. So we have the sine of u plus v is the sine of u cosine of v plus the cosine of u times the sine of v. So the sine of u is the square root of 2 over 2. The cosine of v is the square root of 3 over 2. Add the cosine of u, which is minus the square root of 2 over 2, times the sine of v, which is 1/2. So what you get is you get the square root of 6 minus the square root of 2 all over 4. Okay, then you get the cosine of u plus v from the sheet. Cosine of u, cosine of v, minus sine of u, sine of v. So the cosine of u is negative the square root of 2 over 2. The cosine of v is square root of 3 over 2 minus the sine of u, which is square root of 2 over 2 times the sine of v, which is 1/2. So you see I get negative the square root, quantity 6 square root of 6 plus the square root of 2 all divided by 4. And so this should be very close to negative 1. Let's just see where we are. 11 pi over 12. So that's going to be right here, because 12 pi over 12. So we should have the cosine should be negative, and it should be close to 1, and the sine should be positive. And that's, you can see the case. This is positive because 6 is greater than 2, and this is negative because they're both positive here, and then you change the sign. And the tangent being in the second quadrant should be negative. Okay, so the tangent of u plus v is the tangent of u plus the tangent of v divided by 1 minus the tangent of u times the tangent of v. So let's see, we got u, negative 1. Tangent of u, negative 1. Tangent of v, square root of 3 over 3, divided by 1 minus tangent of u times the tangent of v. And that's your answer. But we got to simplify it here. So what I would do, I think, is I would find a common denominator for both of these fractions. So you'd end up, in the numerator, you have negative 3 plus the square root of 3 over 3. So what I've done is I multiplied the first term by 3 and divided by 3. So that gives me negative 3 over 3, this first term. And then the second one you can do, you've got 1 plus the square root of 3 over 3. So if I multiply this by 3, I'll get 3. And then here it's plus times 3. I don't need to multiply by 3 because it's already got a third. So this is going to be 1 plus the square root of 3, all divided by 3. But now that I have the same denominator, I get negative 3 plus the square root of 3 over 3 plus the square root of 3. And then I multiply the numerator and the denominator by 3 minus the square root of 3. And that's to get the denominator to be without any square roots. So in the numerator, I have negative 3 times 3, so that's negative 9. Outer is negative 3 times negative the square root of 3, so that's plus 3 times the square root of 3. Plus in the inner, I get the same thing, plus 3 times the square root of 3. And then last, I get negative 3, because I have negative square root of positive the square root of 3 times negative the square root of 3. That gives me negative 3. The denominator have 9. 3 times 3 is 9. The inner and outer cancel out. And then I have positive the square root of 3 times negative the square root of 3, so that's negative 3. So I'll get negative 12 plus 6 times the square root of 3 over 6. And then I can divide each of these by 6. I get negative 2 plus the square root of 3. And yeah, this number should be pretty close to 0, and it should be negative because it's in the second quadrant. But let's just use our calculator to do this. Get it in decimal form. So you have negative 2. Negative 2 plus the square root of 3. So I get negative 0.268. And if I just take the tangent of, what have I got here? 11 pi over 12. So do 11 pi over 12. So I need to change my calculator to radians. And then I do the tangent of 11 times pi divided by 12, close parentheses. I get negative 0.268. So I did it right. Okay. The last one for this section is, again, a subtraction problem. And, you know, where is this angle going to be? Well, negative pi over 12 is going to be is about right here, because you've got negative pi over 6, negative pi over 4. So it, based on that, you should have a cosine of negative pi over 12, which should be close to positive 1, because that's the x-coordinate, and the sine of minus pi over 12 should be negative something, negative small, not really small, but not close to 1, because I'm looking at the x and the y coordinates. So that's kind of give me a ballpark. And we have the subtraction here. So we can use the subtraction formula. So we have the sine of negative pi over 12 is going to be equal to, okay, so I look for the subtraction formula. So it's going to be the sine of u minus v, and that's equal to the sine of u cosine of v minus the cosine of u times the sine of v. In our case, u is equal to pi over 6, v is equal to negative pi over 4, actually pi over 4, because we're subtracting it, I think. No, it's negative pi over 4. No, it's positive pi over 4. So we're subtracting v from u. So let's write these things down. So we need the sine of pi over 6, we need the cosine of pi over 6, we need the tangent of pi over 6, and we need the sine of pi over 4, the cosine pi pi over 4, tangent pi over 4. Again, you can read these off of your unit circle. So the sine of pi over 6 is a half. The cosine is the square root of 3 over 2. The tangent is square root of 3 over 3. The sine of pi over 4 is the square root of 2 over 2. The cosine is the square root of 2 over 2. The tangent is 1. So that's all we need. Now we can go ahead and plug it into the first equation. So the sine of negative pi over 12 is equal to the sine of u, which is 1/2, sine of u times the cosine of v, which is the square root of 2 over 2. And we subtract cosine of u, which is the square root of 3 over 2, times the sine of v, which is the square root of 2 over 2. So we end up with the square root of 2 minus the square root of 6 over 4, which is negative, which is what I said it was going to be. So I'm pretty sure that's right. Okay, then we use the cosine. Cosine of u minus v is equal to cosine of u, cosine of v, plus the sine of u, sine of v. So looking over here, cosine of u is the square root of 3 over 2. Cosine of v is the square root of 2 over 2. And then we add the sine of u, which is going to be 1/2 times the sine of v, which is the square root of 2 over 2. So we get the square root of 6 plus the square root of 2 all over 4. And if you add the square root of 6 plus the square root of 2, it's going to be a little bit less than 4. And it's positive, which is what we expected. And then the tangent of u minus v equals u minus v tangent of u minus the tangent of v divided by 1 plus the tangent of u tangent of v. So our tangent here is the square root of 3 over 3 minus the tangent of v, which is 1, divided by 1 plus the tangent of u, which is the square root of 3 over 3, times the tangent of v, which is 1. So we get, if we combine these two again, you'll end up with the square root of 3 minus 3. So we're multiplying this by 3 divided by 3. So that's how you get the 3 in the denominator for the denominator of the numerator pair here. So square root of 3 minus 3 over 3. Okay, in the denominator, we're going to get 3 here. To get the common denominator of 3 again, in the denominator, we're going to multiply this by 3, and the second term already has a denominator of 3. So the 3's cancel out, and we get the square root of 3 minus 3 over 3 plus the square root of 3. And then we would take that expression and multiply the numerator and the denominator by this radical conjugate. So since the original denominator is plus the square root of 3, we're going to multiply minus the square root of 3. And then if we use FOIL, we'll get 3 times the square root of 3 from first. Outer we'll get negative 3. Square root of 3 times negative the square root of 3 is negative 3. Inner we get negative 9. And last we get minus times a minus, so it's plus 3 times the square root of 3. And that's all divided by 9 minus 3. 3 times 3 is 9. The inner and outer cancel out. negative square root of 3 times positive square root of 3 is 3. So the numerator we get 6 because we have 3 and 3. 3 plus 3 is 6. 6 times the square root of 3 minus 12, all divided by 6. And if we plug that in to the calculator, 6 times the square root of 3 minus 12, it's negative 1.6, divided by 6, it's negative 0.268. And again, if I plug into my calculator the tangent of negative pi over 12, make sure the calculator's in radians. So we take the tangent of negative pi divided by 12, close parentheses, and you get negative 0.268. Okay, so that's that section done. Hoping that's all that's in that section. I'm getting tired. Okay, the next one has the same instructions, but we have to decide how to get to those numbers. So we have to add or subtract numbers that are on the unit circle. So let's think about it. If you go to the unit circle, to get a 5, you're going to have to add or subtract something, some multiple of 5, like 45 or 135 or whatever. So I'm going to say maybe 45 degrees. So if I subtract 45 from 285, we get 240. Now the question is 240 on the unit circle, and the answer is yes. Okay. So here's 45. 240 is down here. So this is 240. This is 45. They're both on the unit circle. So we could do that. If we said, if it was, let's say we, if we added 45 to that, we'd get 330, is that right? 285 plus 45 is 330, so we could do that. 330 minus 45, or 240 plus 45, either one would work out okay. So I'm going to use that. Now let's go through all of these first. Okay, so these again, these are twelfths, so that means I'm going to have something fourths. So if I added, I'm going to add pi over 4, which pi over 4 is 3 pi over 12. If you multiply numerator and the denominator by 3. So that means to get 13 pi over 12, we're going to add 10 pi over 12 to 3 pi over 12. So is 10 pi over 12 on the unit circle? Well, if you simplify that, you get 5 pi over 6, which I think is on the unit circle, plus pi over 4. So this is 10 pi over 12 plus 3 pi over 12 is 13 pi over 12. Okay, so that'll work. And you probably could come up with a negative situation. And again, these are twelfths, so you're probably going to subtract something. Let's subtract, the 4 choices we have are pi over 4, which is 3 pi over 12. We could do this one, which is going to be 3 pi over 4, 3 pi over 4, which is 9 pi over 12. So let's try that. We're going to subtract 9 pi over 12. So if we have 2 pi over 12, 2 minus 9 is 7. And 2 pi over 12 is pi over 6. And 9 pi over 12 is 3 pi over 4. The way you could check this, if you just take 1/6 pi over 6 minus 3/4, you'll get negative 0.5833, and you can then go to math, choose fraction, and you get negative 7/12. So this is what I did to make sure I did it right. I took 1/6, which is the coefficient in front of pi. I subtracted 3/4. My calculator gave me negative 0.5833, and then I did the fraction thing. And when I did that, I got negative 7/12, which is what I have. And again, both of these are on the unit circle. So now that I have all that stuff figured out, I can just use the appropriate formulas. So here we're adding 2, here we're adding 2, here we're subtracting. So we can use the same formulas for the first two. So the sine of u plus v equals the sine of u cosine of v plus the cosine of u times sine of v. Let's do the next one. Cosine of u plus v is the cosine of u cosine of v minus the sine of u sine of v, and the tangent of u plus v is the tangent of u plus the tangent of v over 1 minus the tangent of u tangent of v. In our case, the first case for number 6, u is equal to 240 degrees and v is equal to 45 degrees. So we need the sine of 240, the cosine of 240, the tangent of 240. Here we need the sine of 45, cosine of 45, the tangent of 45. Well, we'll do these are the easiest ones because they're in the first quadrant. Square root of 2 over 2, the square root of 2 over 2, 1. As far as 240 is concerned, it's this on the unit circle. So the sine is going to be negative, the cosine is going to be positive, and the tangent is going to be negative. Oh, no, it's going to be, wait a second. They're all going to, sine and cosine are negative. It's in the third quadrant. Tangent is positive. Okay. So 240, you're going to get a cosine of negative 1/2, sine negative the square root of 3 over 2, and the tangent is the sine over the cosine, so you get positive the square root of 3. Because 2's cancel out, you just end up with the square root of 3 over 1. The negatives cancel out, so you get that? Okay. So now we just have to plug in there and simplify. So again, this is number 6. So the sine of, what was it, 285? Is the sine of u, sine of 240, cosine 45 plus cosine 240 times the sine of 45 degrees. So the sine of 240 is negative the square root of 3 over 2. Cosine of 45 is the square root of 2 over 2 plus the cosine of 240, which is negative 1/2, times the cosine, sine of 45, which is the square root of 2 over 2. And you can see we get negative the quantity, square root of 6 plus the square root of 2 all over 4, which is very close to negative 1. And if we look at 285, 285 is about right here, or right about here, because this is 270, so it's very close to that. So it should be close to negative 1, so that's good, makes sense. The cosine of 285, use this formula, is cosine of 240 times the cosine of 45 cosine of 240, cosine 45, minus sine of 240, sine of 45. Cosine of 240 is negative 1/2. Cosine of 45 is the square root of 2 over 2. Sine of 240 is negative the square root of 3 over 2. Sine of 45 is the square root of 2 over 2. So we'd end up, here we got negative times a negative, so we'll get positive square root of 6. Here we get a negative square root of 6 minus the square root of 2, all divided by 4. So this is a positive quantity. Again, going back to our unit circle, we're in the fourth quadrant, which means positive x, which means positive cosine, so that makes sense. And then the tangent of 285 degrees, using this formula, is tangent of 240 plus tangent of 45, all divided by 1 minus the tangent of 240 times the tangent of 45. And this is 285 is in the fourth quadrant, so the tangent should be negative. Okay, so the tangent of 240 is the square root of 3. We add the tangent of 45, which is 1. Divide by 1 minus the tangent of 240, which is square root of 3, times the tangent of 45, which is 1. So we end up with square root of 3 plus 1 divided by 1 minus the square root of 3. So we're going to multiply and divide by 1 plus the square root of 3, because we have this sign change. So in the numerator we get the square root of 3 from the first, we get 3 from the outer, we get 1 from the inner, and we get the square root of 3 from last. And then we divide by 1 minus 3. So 1 times 1 is 1. The inner and outer cancel out. Square root of 3 times negative the square root of 3 is negative 3. So we get we'll get 2 times the square root of 3 plus 4, all divided by negative 2. So you've got the square root of 3 plus the square root of 3. That's 2 times the square root of 3. 3 plus 1 is 4, divided by negative. So this is negative. The numerator is positive, so it's negative, which is what we expected for the tangent. So that's a tangent of 285. Okay, so the next one is this one right here, number 7. So what I'm going to do is I'm going to keep those formulas. I'm going to take this stuff and shift it out of the way. I'm going to delete it. So 7. So we need all the trig functions here. We need the sine of 5 pi over 6. We need the cosine 5 pi over 6. We need the tangent 5 pi over 6. We need the sine of pi over 4. Cosine pi over 4. Tangent pi over 4. Which we've done those before. Same as 45 degrees. So you get square root of 2 over 2, square root of 2 over 2, 1. Now, 5 pi over 6 is over here. So if I draw this unit circle, I'm going to have a negative cosine, and as a consequence, I'm going to have a negative tangent. The cosine is the x-coordinate, which is going to be the square root of 3 over 2, and the y-coordinate is a half. And because I'm dividing sine by cosine, I'm going to get negative the square root of 3 over 3. If these are switched, then I'd have the square root of 3. Okay, so now I can use the formulas. So the sine of whatever the original angle was, 13 pi over 12, equals the sine of the sine of 5 pi over 6 times the cosine of pi over 4 plus the cosine 5 pi over 6 times the sine of pi over 4. So the sine of 5 pi over 6 is a half. Cosine of pi over 4 is square root of 2 over 2 plus the cosine of 5 pi over 6, which is the square root of 3 over 2, times the sine of pi over 4, which is the square root of 2 over 2. And this is negative the square root of 3 over 2. So what you'll get is you'll get the square root of 2 minus the square root of 6 over 4, which is negative, which 13 pi over, so where's 13 pi over 12? Well, 13 pi over 12 is right here, because pi is 12 pi over 12, so it's just slightly down from this. So the cosine is negative and the sine is negative, so these both should end up being negative, and consequently the tangent should be positive. Okay, so we got the cosine of 13 pi over 12 is the cosine of 5 pi over 6 times the cosine of pi over 4 minus the sine of 5 pi over 6 times the cosine, or times the sine of pi over 4. Okay, so let's plug them in there. Cosine of 5 pi over 6 is negative the square root of 3 over 2. Cosine of pi over 4 is the square root of 2 over 2. And then we subtract the sine of 5 pi over 6, and we multiply that by the sine of pi over 4. So we get that. So what we'll get is negative the quantity square root of 6 plus the square root of 2 all over 4. Because you get a negative from both of them, factor that out. These become the square root of 6, this becomes square root of 2. Remember, these added together are very close to 4. And if you look at it, here's 13 pi over 12, so you should have cosine that's negative, that's close to negative 1. And then finally, the tangent of 13 pi over 12 is equal to the tangent of 5 pi over 6 plus the tangent of pi over 4 divided by 1 minus the tangent of 5 pi over 6 times the tangent of pi over 4. So the tangent of 5 pi over 6 is negative the square root of 3 over 3. Tangent pi over 4 is 1 divided by 1 minus tangent of 5 pi over 6, which is negative the square root of 3 over 3 times tangent of pi over 4, which is 1. And again, what we'll do is find a common denominator. So the numerator becomes negative the square root of 3 plus 3 over 3. So this becomes 3 over 3. If you add that, then you have the same denominator. You can do that. And over here we have negative times a negative. So it'll be 3 plus the square root of 3 over 3. So this becomes positive, so it's 1 plus the square root of 3 over 3. Multiply this by 3 over 3, you'll get 3 over 3. Add the two things together. Now they both have the same denominator, so you can just cancel those out. So you get negative the square root of 3 plus 3 divided by 3 plus the square root of 3. And then you multiply and divide by 3 minus the square root of 3. 3 minus the square root of 3. So in the numerator we get negative 3 times the square root of 3. First outer we get plus 3. Negative the square root of 3 times negative the square root of 3 is positive 3. Inner we get plus 9, 3 times 3. And the last we get negative 3 times the square root of 3. And you divide that all by 9 minus 3. 3 times 3 is 9. The inner and outer cancel out. Square root of 3 times the square root of 3 is 3 with a negative sign. So if you simplify the numerator, you'll get negative 6 square root of 3 plus 12 divided by 6, which is negative the square root of 3 plus 12 and plus 2. And that's going to give you a positive number because the square root of 3 is less than 2, so when you subtract it, you get a positive number. And that makes sense from the tangent is positive in the third quadrant. So tangent of 13 pi over 12. Okay. How many more of these got? It's taking forever, but oh my gosh. Oh, it's going to take forever. Okay, and the last one, we have to use the subtraction formulas. So the sine of u minus v is sine of u cosine of v minus the cosine of v sine of u. That's not right. Sine of u cosine of v cosine of u minus, yeah, this is right. Okay, cosine of u sine of v. The cosine of u minus v is cosine of u cosine of v plus the sine of u sine of v, and the tangent of u minus v is the tangent of u minus the tangent of v divided by 1 plus tangent of u tangent of v. And we need to know the sine pi over 6, the cosine of pi over 6, the tangent of pi over 6. We need to know the sine of 3 pi over 4, the cosine of 3 pi over 4, tangent 3 pi over 4. So again, you can look up on your unit circle. So the sine of pi over 6 is a half. Cosine is the square root of 3 over 2. Tangent is square root of 3 over 3. And this is in the second quadrant. 3 pi over 4 is in the second quadrant, so the sine is positive. Cosine is negative. Tangent is negative. So then you can just plug them into the formula. So the sine of whatever this difference is, negative 7 pi over 12, is going to be equal to the sine of pi over 6 cosine of 3 pi over 4 minus cosine of pi over 6 sine of 3 pi over 4. Sine of pi over 6 is a half. Cosine of 3 pi over 4 is negative the square root of 2 over 2. Subtract the cosine of pi over 6, which is the square root of 3 over 2, times the sine of 3 pi over 4, which is the square root of 2 over 2. So what you get is you get negative the square root, negative the quantity, square root of 2 plus the square root of 6 over 4. The cosine of negative 7 pi over 12 is, using this formula, it's the cosine of pi over 6 cosine 3 pi over 4 plus the sine of pi over 6 sine 3 pi over 4. Cosine of pi over 6 is square root of 3 over 2. Cosine of 3 pi over 4 is negative the square root of 2 over 2. Sine of pi over 6 is a half. Sine of 3 pi over 4 is the square root of 2 over 2. So what I get is the square root of 2 minus the square root of 6 over 4. So this is negative, and negative 7 pi over 12, yeah, where is that? Well, 6 pi over 12 is negative pi over 2, so it should be right here. So we should have both negative sine and cosines, which we do. And the tangent should be positive, so we get the tangent of negative 7 pi over 12 is equal to the tangent of pi over 6. I guess I should write these down. So you get the tangent of pi over 6 minus the tangent of 3 pi over 4 divided by 1 plus the tangent of pi over 6 times the tangent of 3 pi over 4. So the tangent of pi over 6 is the square root of 3 over 3. Tangent of 3 pi over 4 is negative 1. All divided by 1 plus the tangent of pi over 6, which is square root of 3 over 3 times the tangent of 3 pi over 4, which is negative 1. So here we're going to have the square root of 3 plus 3 divided by 3, because you get negative 1 times 1 is negative 1 is positive 1. Here we're going to have 3 minus the square root of 3 over 3. So these cancel out. And we're left with the square root of 3 plus 3 divided by 3 minus the square root of 3. And then you multiply and divide by 3 plus the square root of 3. So in the numerator we get 3 square root of 3 plus 3 plus 9 plus 3 times the square root of 3, all divided by 9 minus 3. And so in the numerator we have 6 times the square root of 3 plus 12 over 6, which is the square root of 3 plus 2. And that's positive, which is what we expected it to be. Okay. Okay, so that's the last one of that group. Moving on.